Right. I got here early, so I'm impatient. Let's get this show on the road. It's going to be a pretty full packed community call. So thanks everybody for being on. The agenda today is we have updates from the business and event side from Anna. Then we have a very cool, our hackathon winner from the Polygon hackathon here, Bazaar Zero. Welcome and looking forward to your presentation after that. Then we'll have a couple of short tech updates from the team. I think Folix has a few things. And then we have a couple of deep dives. One is Alexei showcasing the latest release of Registry, and followed by Mike with a deep dive on all the cool things and changes and upcoming changes in AquaVM. All right, as I'm already tired, Anna, you want to kick it off? There's a few things, and then we have a couple of deep. That sounded like me, and it wasn't me.
Yeah, somebody has echo problem. All right. Screen. Here? Mhm. Yeah, I'm good. Okay. Give me a sign if you can. All right. First things first, wanted to show you our community calls wiki. So we are just collecting all the history of the community calls, and you can see the next community call or today's community call. You can go inside here and see what are the hackathons we have, what is the link, and there will be also live stream and recording link. We are live streaming today to YouTube. And in every video, we put links, the references to this wiki, so you can easily find it, or you can find it in our Discord. So let me just walk you through the upcoming events and hackathons. For the hackathons, we have Lumos Labs hackathon that's going on right now, and you can still join. They have a lot of activities. Today there was Twitter Spaces, and they have workshops and a lot of tracks you can see from all different sponsors as well as from us. There is 5,000 USD you can get for building the best Web3 tooling, API, SDK services, and etc. etc. Check out here or in the GitHub Fluence Labs Lumos Hackathon. Then one of the upcoming hackathons in the next year we are going to have, that's in person, that's in ETH Denver from end of February to beginning of March. We will tell more about that. We're just signing up for this one. That's going to be huge next year. That's also virtual. That's always in person and virtual. And then other upcoming hackathons, we're not necessarily participating, but if you guys want, you can check them out. It's East San Francisco. That's in person. If you're in the US, if you're in San Francisco, check it out. Web3 weekend, that's online, virtual from ETH Global, end of November. Check out their website. Gitcoin, as always, you probably know the Gitcoin platform. They have a month of the hackathon, and ETH India, that's in person, will be huge. Beginning of December, we are considering of participation there with Fluence to sponsor bounties, but not yet decided. And in October, end of October, beginning of November, our team will be in Lisbon, in Portugal. If you're there, the events are following that we recommend you to visit and that we are going to participate. That's the Lab Week. That's our partners. That's our friends. Protocol Labs is organizing. There are lots of different activities. You can check Lab Week website. You will see, sorry, it's a bit lagging. You will see they have different summits, different meetups, whatnot. Also IPFS Camp, Phil Lisbon, the same as it was in Singapore, and ETH Lisbon, the hackathon that is organized by 1KX and other partners. And we are going to have our own Fluence meetups October 31st, November 1st, and November 3rd. So feel free to join. Again, all the links we will share later in Discord and Telegram. So you'll see that. And for the other events that are coming up, that's Compute Over Data, that's also part of Lab Week, and other different conferences. Also do check it out if you're interested. That's it from my side. Thank you so much.
All right, thank you, Anna. Anybody have any questions? No. All right. Well, Bazaar Zero it is. So in the recent hackathon, Polygon hackathon, Bazaar Zero was an entry, and they worked on a project, and they can explain this much better than I can. Basically, decentralizing marketplaces like OpenSea, Rarible, etc. And they're not the first project to do it, but they had some really interesting wrinkles in it and improvements, including the ability to bundle multiple assets, so ERC20, 721, and 1155 into a single product, and had some interesting approaches in terms of provability using zero knowledge proofs. Anyway, let me hand it over to you guys. Just introduce yourself and show everybody what you did.
Hi guys. Yeah, we are from Bazaar Zero. We won again. Second time for the hackathon. First one that we did is was in the 80s, Dosa project. So this is our second project using Fluence. It's a hackathon. But for this one, second, let me share. One second, let me switch on live. Share you the videos. So big brief project. Uh, okay, we have problem here sharing our videos. Can someone help us to play the video and share it inside the what you call the general help us to share the videos?
There should be on the left side. There should be on the left bar. There should be a share screen button in Discord.
So okay, we need to restart the Discord actually.
So now it should come up. Let's check again.
One second,
Did you find the button, the screen sharing button?
Yeah, we find it. Just that we need to give permission to the Discord.
Okay.
Nampak?
All right.
We need to
Mute. Mute. Tak, mute.
go to Discord.
Hmm?
Open the Discord. Click this one and this two. You can see the video.
No. There is no sound, right?
Yes. All right, now it's gone.
We are building a match up future marketplace into a single network, focusing on Polygon, the NFT, tooling infrastructure, everything is okay. Close the Sequence wallet / Python. So it means that anyone can open the
Okay, I don't really see anything, and I can barely hear anything.
Yeah.
All right, the picture is back now.
The voice, the device to device. Tak, tu lah.
off sekejap lah, IP masuk dulu.
Hmm?
Kita pilih kat situ.
Kita sama je. Aku punya setting tak.
Oh, ya.
Kalau pakai mic ni, mic ni boleh tak?
Tak boleh pakai mic. Dia kena live. Kau boleh tak? Dia boleh tak? Kau terus share.
Silakan dulu. Okay, so we reshare again. Sorry about that. Can you see it? Sorry.
Also have echo, maybe one.
Yes, yeah, sorry about that. Okay, it's clear now. Okay, can you hear me?
Yes.
All right. So, okay, let me play the video. Sorry about that. Oh, sorry. It's okay this way. Can you hear the sound?
Yep.
All right.
No sound. How about instead of doing the video, why don't you just tell us a little bit how you use the semaphore zero knowledge proof and how do you use Fluence in your overall situation? Maybe that
All
would be
right.
helpful.
Okay. Okay. Sorry about that. So didn't expect the video having a problem. Okay. So the first original idea we actually have is actually that we want to build a new type of what we call a cross-chain marketplace, right? So there are two things that are main focus that we are trying to look at is we want to play around with zero knowledge proof, and we actually want to play more on Fluence, using a Fluence to build a more what we call peer-to-peer communications. So I mean the project was inspired by Open Bazaar. So we like the idea of Open Bazaar that everyone can actually open up their own what you call this can open up their own shops, and they can close the shop when they like it, they can open when they like it and things like that. So so based on that kind of what kind of inspiration that we actually found out that actually someone actually built using Bazaar EX, if I'm not mistaken, for Fluence. So that's actually our first foray in terms of understanding how Fluence actually manage how to use Fluence together with the NFT in terms of the market trading. But for Bazaar EX, the main focus is actually to trade the NFT. And an NFT is actually a physical product, whereby in ours is actually to do a transferable, like a bundle of the projects, right? So what the first thing that we actually do that on that point is actually that one thing is that we need to build is actually that we are using Polygon actually. For one thing is actually to generate mean for all kind of a smart contract, but we need to have some sort of control. So it means that what we want to do is actually that they can only mint the NFT, whereby I'm sorry about that. The NFT is actually a special container NFT. So you can actually put more items, more assets inside the NFT. Example, you can put a ERC20, 1155, and 721 into the NFT, right? So the first step is that every nodes will have their own sequence wallets, right? So I think because I can't share the video, but I did share it inside the general group, so anyone actually can take a look at the videos to understand more on that thing. So we already shut down the server for the applications, right? So every node we have their own what we call a smart contract wallet. So any user that want to open a shop will need to actually open up a wallet. So instead of, because one thing what we want to avoid is the same thing as OpenSea, because it means that every time you want to sell the product or that, the product is not actually with you, the product is actually with OpenSea, right? So it defeats the purpose of a decentralization, whereby that we have a full ownership of the product. Once we transfer the OpenSea, the ownership is actually based on the OpenSea. So using a Fluence, right? So it means that when you create the nodes, example that so when you create the nodes, all that, so together with the sequence wallet, you can actually create what we call a smart contract on every node. Sorry, my bad. A wallet for every node. So every time you want to sell the product, all that, the NFT are being transferred inside the wallet. But that wallet are still under the what we call the user control. So if the user can take it out the item as they need, but as they take out the item, so-called item automatically sale. The item automatically be cancelled. Alright. Okay. Sorry, I'm actually caught off guard without the video. I guess for the ZKP one, we're actually using a semaphore. So what we do is just that, so you can only mint this container NFT throughout the nodes. You can't actually go into the smart contract and try to mint it directly. So what you do is that we are actually using if you look at the videos that before you can do the mint, you need to get the proof from the another smart contract of a semaphore smart contract, a ZKP smart contract, right? once you get the proof, whereby the proofs are being sent through one of the Fluence, we're using a Fluence JS as what we call to store the proof. So once you get that proof, then only you can min it from your own nodes for that. Then after that, after you do the sales, all that container are actually been destroyed, and you actually get the item whatever been bundled inside there. So you can actually bundle up ERC20, 1155 and 721. So it means that you can pair a 721 and an NFT and also a token together as a single sales. So in the hope that you actually give more values to the marketplace. So one thing that we actually take a look on this is actually using a registry system for the first time, right? And we actually pull out how we do the search is actually that the search is actually happening on real time. You check out the nodes that are live on that point, right? So any item are being published inside the nodes, are being pulled from the network itself, right?
I got a quick question here before you go on. So semaphore,
Yeah.
so
Yes.
semaphore proof basically proof membership in a group, right?
Correct.
What's the group? Is it the nodes? Is that the group?
So the node, yes, correct. Actually, we have two types of nodes. Actually, in this case, one is a seller node, another one is actually what we call application nodes. So this is actually the idea that anyone can build any application from this marketplace, right? So if you don't like my application, like the marketplace that I open, anyone can open another marketplace with a different kind of royalty. That's the example that we look. But every kind of node, basically the seller nodes, are being registered to the semaphore, right? I mean, it's as a proof. To get the proof is that you need, at the first time when you register an account, right? When you open an account, you automatically are being registered as a proof. So that node will register as a seller. That makes sense.
No, that makes sense. So when you say node, what exactly is that node now? That seller node, what is it?
Okay, so for this to work, we're actually using a Fluence JS. So every Fluence JS is actually that each one of we call it a nodes, right? So every Fluence JS is a nodes, but it's like node down, all this kind of thing. So it means that every time people want to sell it, they can actually deploy it locally, right? At their own computer. So they can, actually we didn't actually complete it throughout the hackathon, that they can deploy throughout a Docker or things like that. So it means that you can just clone the code and run it directly, the Fluence, they automatically bind it to the network, right? Throughout the network.
Very cool.
Okay.
So all right, yeah. Thank you.
All right. So yeah. So that's actually our first project. Actually, the one that we want to try is actually the how actually we can use actually we do an experiment for this project is actually try to look in to be a new type of marketplace using a Fluence, right? So it means Fluence as a base, what we call as a core communications, right? The core integration that is actually directly connected to the smart contracts, right? Yeah, I mean, we will share some information you can check out on the videos. So and actually inside the videos we have the GitHub that you can actually check it out on that part.
Okay, now before I interrupted you, you were talking about the registry.
Yes. So I mean, okay, but that's actually our first time playing with registry. I think that it's something that we learned it from the last call, right? Last community call. So it's something that we want to look, because how I understand about the registry is, sorry, you should ask the question. I answer it before you ask the question, right?
No, I don't have a question. I just wanted to make sure you're back where I interrupted you. You were talking about registry, and I have no question. I just wanted to hear what you had to say about registry.
Okay, I mean, in terms of the registry, it doesn't have much information yet, because that when we play around, I mean, we do understand from the Aqua book all that, but that actually that's our first experiment in registry. So as we understand, the registry is actually to register the node for you to have the search. So what we do is actually that when we actually deploy another search node, so basically there are two types of node. One is a seller node, another one is a search node, right? So the search node is so-called like a marketplace node that they actually pull all the information from the seller node, the available seller node. So we are using a registry that to register this separate type of what we call separate type of nodes. So it means that one is a seller node. So it means that when we do the search, they only search the nodes that have been registered as a seller only. I'm not sure is it the right way of using a registry or not, but to categorize the node to.
We got Alex A on the call. He's going to talk about registry a little bit, and definitely we should figure out to establish a channel or whatever in Slack where we can help you out a little bit.
Yeah, all right, that'd be great.
Okay. And the other thing, so I only have one more question for you. You're using Fluence.js as your peer implementation, and have you like ever looked? Does everything you do, does it translate into WebAssembly on the Rust node, or is it very specific to Fluence.js?
I mean, because that we both three of us is our background is a Node.js developer, right? So actually, Fluence.js is our entry point to Fluence. Definitely, we did study about the Rust. It means you have more tools and definitely are more easier to deploy and to manage. But because that when we do all this experiment, we guess that instead of we are trying to focus a lot on the language part of it, we want to focus the beauty of Fluence first. So what it can be what it can be done. But I do understand that if you actually go to Rust, you can actually do a lot more things compared to.
Well, I'm not telling you to go to Rust. I just was wondering what your process was, and you answered it from a tooling and background perspective. So very cool.
All right. Okay. So yeah, that's basically about the Open Bazaar that we work on for the last hackathon. Hopefully, we can do more things. We want to bring out the products out as well to build out the first, hopefully, a multi-chain marketplace NFT for NFTs. Okay. I guess that's all from my side.
Very
From our
much
side,
for the
actually.
presentation.
All right.
Cool. And we'll stay in touch. We'll try and figure out somewhere we can help you out with registry a little bit.
Yeah, that'd be
And
great.
anybody else have any questions? No? All right. I think the next part was what's the time? 12:31. Felix, do you want to give like a brief update on all things tech really quick?
I think our main updates are from Alexei for registry and from Mike.
Okay. Then we'll go straight to Alexei, who actually has updates on registry, which of course is very timely for the Bazaar team. So, all right, Alexei, all yours.
Yeah, do you see it? Can you hear me? Do you hear
Yes,
me?
yes.
Yeah.
It's loading.
So,
Yes.
I will tell you about latest registry updates. As you can remember or not, registry is a service that provides advertisement and discovery for services. It creates relations between unique identifiers and the services. And we can resolve peer ID and service ID of a group of service by one identifier. And it's a built-in service. It's available on every Fluence node. So why is updates? There is something wrong because we have previously very obscure terminology like providers, not providers. It was hard to tell about it. It was hard to understand. And in fact, there is not a lot of difference between these providers, as we call it, because it was misdesigned. Also, there was broken life cycles because it was impossible to renew a record without JS client if record corresponds to the service on the Rust peer. Also, there was no way to remove record. You can register some service or record, but you can't remove it. You just need to wait like a day, and it's strange. Also, we had a very complicated API with strange namings because because of first thing with obscure terminology. So, what's new? We come up with a more clear terminology. We have a resource, it's like a key in key-value storage, and we have a records, it's a values in with storage, and record represents routing information about registered service, like peer ID, service ID, and optional relay ID if we deal with JS peer. We removed providers and especially not providers from terminology, and we have only records. Records for services with different peer IDs. Also, we fixed life cycles. We've introducing 6 service for registry for every Rust peer. So peers can commit to the record that this peer hosts some service. For now, we have no checkings except of tetraplets, and we can sign anything from the registry, but later we will add some challenge solution-based solution to it. Record contain 2 signatures from issuer who wants to register some service and from the peers where is service hosted. So with that, Rust peers can renew local records automatically with cron jobs, scheduled scripts, and it's cool. So for record removal, I added a thing called tombstones. It's something like Cassandra tombstones or other tombstones in distributed systems. It's just a record, but it replaces older record and keep some time, and eventually record will be removed from all the network. And it's distributed like records, and it's almost similar. Also, I updated APIs. It's more shorter and clearer. We can create resource, we can resolve resource, get resource ID, register service record, and the register service, and find all the records for the some resource ID. So it's become really simple to create resource and register both local service if we deal with JS peer or remote service on the network like Krasnodar or testnet. It's just different peer IDs. Sorry. Also, with how it looks to resolve resource and get all the records, and we can go to the peer ID, advertise peer ID, and do something with the service which we want. This looks like we can unregister service and check the result. I'm sorry, my cat doing something strange. Also, I created first Aqua API tests. It's the first service with a test for Aqua. It's just Python runner that run PyTest, and it checks everything in API. And it's cool because we will build up, we will include it in CI, and it in registry becomes more stable. Also, I created step-by-step example with Fluence CLI. It covers creating the service, registering service in the registry, registering JS peer service, resolving it, and removing. Like, it's all API in it. What's next with registry? We will have an internal hackathon, which help us to test the stability of registry. Also, we already started to add challenge solution permission management for resource, like owner of the resource can decide who can add records for it. Also, I think about resources removal because we can remove records, but we don't manage to remove resources. Also, I will add more tests and examples, and it will be good. That's all. Thank you. If you have any question.
Thank you, Alexei. Yeah, questions, anybody?
No? Okay, thank you.
All right. Mike, you're up next.
Can you hear me
Yes.
and see my screen in 1, 2? Yep, and now you should see it. Yep, is it okay?
Yes, it's excellent.
Cool, thank you. So I would like to share some progress on the machine department side. So especially on the AquaVM side, and on this picture you could see the diagram of feature dependency and feature progress that we had at the end of August this year. Yes, and at the end of August, our plan was to support, first of all, determinism on the AquaVM. So here you can see arrows that represent different tracks on the AquaVM side. And on September, so we implemented a lot of features, and the most notable ones they are was on the determinism track. So here you can see that we implemented several features. So next slides I will discuss shortly about each of this feature. But the main agenda here is that like determinism is almost here, is almost an AquaVM. By almost I mean that it's implemented, but one of this feature, reduce stream scope, is not yet merged because it's a breaking change, and next week we will have the internal hackathon, and we plan to merge it next, so like in 2 weeks, and after that the AquaVM would be deterministic and versioned. So what does it mean to be deterministic? It means that AquaVM won't break by using inappropriate values in on appropriate size, on appropriate places. So we will see next slide how it could be obtained. How could you write some code on Aqua, or well, not now it's fixed, but previously you could write some code on Aqua, and some very complex scenarios it could break. Also, we had progress on other tracks. So one maybe of the most valuable here is the support of length functor. So it's very useful thing. Though it looks simple, but from the implementation perspective, it's quite complex. Also, we working on the hardening of AquaVM. By hardening here, I mean that we are trying to make AquaVM as stable as possible, and to make it more stable and more, more mature in terms of some different scenarios, in terms of some probability of having bugs and all this. So here you can see that we implemented some MISC stuff like dedicated types for air positions in script. So we improved tests, especially in tests for canon instruction that was introduced in previous months, and we found some bugs with this canon instruction. And also we are working now on a formalization of AquaVM. So we're working on a specification on K framework, and then we plan to we plan to make model check-in with TLA Plus. So we're working on the site. Also, we introduced a new instruction called never. So it's quite simple instruction, but really useful for some scenarios. So it's basically all for like the whole picture of the AquaVM site progress. So let's dig into details a bit. So regarding length functor, so the idea here is quite simple. In air previously, it was impossible to get size of value. In that, like on the AquaVM side, we have 3 different value types. First one is scalar, they're JSON based. Second one is stream. streams, they are seriality-like, and they are, I would say, they kind of array-based. And the third one is Canon canonicalized streams. They are also array-based, and we implemented one functor that allows you to obtain length of Canon streams as well as length of array-based, array-type JSON values I mean scalars. So it looks pretty simple. So here we could just write dot length, and it's quite similar to what we have with lambdas, but syntax a bit different because lambda starts with this sign, with a dollar, with dot and a dollar sign. For functors, you shouldn't use it, and but it's quite difficult from an internal side because so there are some issues with tetherplets and like all stuff with canonicalized streams and all of this. So, but it's implemented, it's merged and delivered. So, and Aqua already supported. But previously, from the developer perspective who uses on the Aqua, it also was possible to obtain length of a stream, of a scalar, and all of this. But it was implemented with a service call. So it was kind of hack because like to obtain length, you just need to call a service written on WebAssembly that just return to you size, and it was kind of tricky and not an optimal, of course. And we are working on the site. We have we have some thoughts about introducing new functors that, so especially for example for math operations, because they're quite simple, and now for math also service calls are used, and that's also not so optimal. Next one is the never instruction. Never instruction marks a subgraph is incomplete. So regarding subgraph, like here internally in the interpreter is presented as a graph, not a tree but a graph because cycles are possible. They come from recursive streams, and there are two instructions, two simplest instructions. The first one is null, and null is just does nothing. Yes, it just not mark subgraph as whatever. It just nothing. And never here marks subgraph as incomplete. It means that, for example, for this pattern, yes, if we have instruction, let me use this font. So if we have the following pattern, okay, let's say call here. So from the interpreter perspective, so this instruction reads as a left subgraph, and this one is a right subgraph, and sec or sequential combinator. Yes, it's a combinator that comes directly from PyCalculus, and it works in the following way: that it executes right subtree if and only if left was executed successfully. And in this pattern, never marks this subgraph as incomplete, and a sequential combinator knows that it's incomplete and doesn't call this right subgraph is call. So this call will never be called, actually.
You still with us, Mike? Or did the never operator just kick in and you never executed? Right, I think we lost Mike. Are you back, Mike? All right, he's not back. Okay, well, in that case, I think that concludes the presentations from the Fluence team. Mike? No. From the Fluence team. So anybody have any questions about business, upcoming hackathons, events? Anybody who wants to meet up in Lisbon? Any questions for the presentations about Registry or AquaVM, which Mike just brought? Anybody? Anything?
Hello. Hi.
Hello.
I have a question regarding the registry just now.
Yes.
Oh, all right. Okay. So that we try to do that. What we actually tried to do last time is to actually create a dynamic peer. So every user we have on the front end side, they generate a new type of peer, and this peer will be registered to the seller, right? So because I'm not sure that we do it correctly or not, that actually that we didn't actually attach any key to the peer. So all the peer need to be registered inside a registry. So at one point we realized that actually that we make the registry become like saturated by a lot of peers, whereby not a lot of it that are not as actually used or active, right? So I saw just now inside the documentation, there's actually no way of removing that peer. Is it?
Yeah, so you can create resource for group of peers, register peers for this resource, and remove unwanted as you wish. Yeah, it's already live. Yeah.
Okay. So we can actually remove them now, the peer that we don't need.
Yeah, just update to the latest registry and Aqua. Yeah, and you can do it.
Okay, but one thing is that we foresee is that because the peer are dynamically generated, like automatically generated, how we know that the peer are not needed, which peer are active, which peer are not active.
Whereas no health checks now, you should do your own. Like someone should
Oh.
someone should do it. It's not automatic. Register just a basic block. You can register and register, but you should decide by your own who need to unregister. Or
Right.
maybe if it's your custom peers, we can unregister by exit of process, for example, and register on start.
Okay. All right. So it means that we need some sort of process or service actually running to check all the peers. Like using, like what you say, we build in our own house check, like pinging back to the nodes or something like that. Lah.
Yeah, you should have the notion of a heartbeat somewhere.
So it's not built in, we need to build that heartbeat one, the health check.
Yes. So one thing you could do is for every peer, if you have a ping function,
Oh, okay.
like automatically, and then you can
Alright.
just go through that, right? And then you can just do garbage collection on that if you want to.
The same process that I think if I'm not mistaken, is every hour they're actually gonna do the cleanup automatically. That's actually still running, am I right?
Alexei?
Can you repeat the questions? Sorry.
Once you know what hourly garbage collection looks like.
Garbage collection. Okay. For now, if you register some service on the Rust peer, it renews automatically. Like until you unregister it, it will be forever in the network. Yeah. If you register record for JS peer, like you create service on JS peer, you should renew it by your own, and you can stop renewing, you can unregister it, and yeah, that's all. So garbage collection is actual. Sorry. Okay. it's garbage collected if you stop it renewing. To stop it renewing, you should stop renew on JS peer, or you should unregister it on the Rust peer. That's all. And also, for now, only issuer of the record can remove this record. But maybe it's good to think that owner of the resource can may delete this record. How do you think about it?
Yeah,
Okay.
we need to
All
discuss.
right.
Did that answer your question? We can follow up offline if you have more questions.
Yep.
Okay.
Right. Thank you.
All right. I think Mike is back. Mike, are you back? You
Yeah,
do you want to finish up?
yep, I can finish up if you have time.
Yeah, we have time. Finish up.
Okay.
Are there still space for other questions?
Yes. Who has questions?
Morgan here.
Hi, Morgan.
There. I just wanted to clarify from the prior question there. You mentioned a ping, sort of like a ping timer. From my understanding with Fluence, it's more of a you push to a Fluence node and then you sort of like pull the response, and you can't necessarily push from a Fluence node to a front end. Is that
Yeah, you would use a scheduled script for that.
scheduled script?
Yeah.
Okay. That would be a script developed in Rust?
In Aqua.
Oh, okay, in Aqua. Okay. And I'll probably have some questions afterwards. But
Okay.
I had another question regarding sort of front-end use case with being able to use Fluence as a type of impression counter on things like a decentralized website. My current use case is looking at something like if you were to have some service that was basically using a SaaS model of some sort for things like UTF or Unicode signs or logos, could you use Fluence as a type of intermediary or middleware between websites developed? So, for example, if you had an interface that had certain UTFs and they had certain counts or clicks or something like that, and there was let's say a backend with Ethereum, but using Fluence as like the main middleware for activity. Is that something that's like can be doable or has been done in the past or something like that?
Doable, yes. Done in the past, I don't think so.
Okay, cool. And can you? I haven't looked at, or I haven't encountered this in the past. Can you see, like, could you? I guess it could be something like, I've seen examples in the past where you've had online, seeing like how many online users there are for a chat, for example. But could you see how many online connections there are from like thinking about if you think about like the hypertext space of like websites and like their relations, could you build like a mapping of these UTF symbols in sort of like a network that's like shareable and public?
I'm thinking. Anybody else from the team wants to chime in? Don't wait for me.
I can reframe the question if it's
So
unclear.
basically, you want an impression counter of, and you wanna represent that as a graph. Is that correct?
Yeah, exactly. In a live graph, so you could like see people join and close, but you could be able to see the actual UTFs being displayed in some type of visualization. And ideally, this would be, I mean, that's sort of like a bare bone test case I'm thinking about right now for
So the real challenge is actually acquiring the live connections, right? That's the challenge. The rest is just data processing.
Okay, is there a max live connection for Fluence nodes?
Well, it's it's peer to peer, right? So you have your limit on the neighborhoods, but you can extend it through cache. And
Okay.
somebody did something about that? Didn't Jura do something about that in terms of capturing all the live connections and then visualizing them? Folex, do you remember?
Graphing online nodes, not the connections.
Okay.
But if you want to track connections to front ends, you can do that by storing meta information about this connection and maintaining it.
Right.
So yeah, that's possible.
Where would the state be held, or is is there even a necessity to hold any state if you just have connections being created? And I guess I need to clarify what is the max for the neighborhood Fluence currently?
State should be somewhere. You can maybe access the Rust peer connection information if we provide the API for that, but I think it's enough to hold the state either in front ends and share it, or on Rust services like WebAssembly services, have a registry of users for your application, like participants, maintaining it there by pinging everyone who's online periodically. That's how it's usually done on backends, and it's possible on Fluence.
Okay, cool. And I guess the final question there is what's the max in a neighborhood? That's the I heard that.
Well, you can specify how many nodes you want to retrieve from the neighborhood. You can even say 100 or 1000, but default is 25 or 20, just 20. So it just depends on what you want. But usually 20 as a replication is enough for most applications. Usually it's 3, 4, or 5. So 20 is more than enough.
Okay. Right.
If you start developing that, you should ping us with any questions. It's rather clear target, so it should be easily done.
Yeah. Okay. Thank you very much. Yeah. I'm still every time I dig into Fluence, I always hit a bit of a wall with some of the developing the Rust services, and then some of the syntax with Aqua. But I do have this application that I would love to test in some type of playground. I'll be developing some things in relation to the payment. Basically, these UTFs would be streams or superfluid streams that people would have donators to, and in order to use them in your site, you kind of open up a future yield on with AP Wine. I'm looking to do that at the Bogota hackathon coming up, but I know you guys aren't, you folks aren't hackathon sponsors for it, but I feel like there's still this other piece that might trickle out afterwards and be a test ground to actually develop with it. So, I've done a little bit of it in the past, but yeah. Thank you. Yeah, that was really helpful.
Okay, cool. Mike, you want to kick it in and kick it off? And
how much time do you have?
How much time do you need?
Let's say something about 7 minutes.
You got 7 minutes.
Okay.
Do it.
Let me try. Let me try to share screen. So there was something with Discord on my side. So hope you see it.
Yep.
So I ended somewhere here, yes, on a never instruction.
Yep.
Cool. So I said that in this pattern. So if you have the simple Aqua script, So on this side, if we put never on the web subgraph, then never marks this web subgraph is as incomplete. In this case, this right subgraph would never be called. So, and why this never instruction is needed actually? So the main purpose of introducing this instruction was to allow fault works more precisely and have more, more advanced semantics. So let's consider how it works now and what's the change that was done and how never is used to follow the change. So if you see on this this box, we can see like simple AquaScript with simple fault. So on this fault, we have this sequential combinator as a body. And here we have next, and next works in the following way that it takes iterator, move it to the next value on a stream or in a scalar that we are used as an iterable in fault. And if there are no such value, then next, oh sorry, if there is value in a stream, that it move iterator to next value, and then call recursively this body, start of a body of a fault. If no values, then it calls, then it recursively exits from this like recursive chain. So why it's needed? Because actually there could be instruction after next, and they would be recursively called. But okay, let's imagine that there are no such instructions. That's such a simple body, and how it could be executed. So let's say the stream has two values, so v1 and v2, and the execution flow would look like this. So first of all, AquaVM executes flow itself. It adjusts iterables, iterator, and so on. And then next sequential combinator would be called. And so actually it looks like a graph traversal. And more precisely, it's so-called pre-order graph traversal. So in this pre-order graph traversal, we execute instructions, then move to the left subgraph, execute the whole left subgraph, and then move to the right subgraph. So the left subgraph of a call here is only one, of this CQ is only one this instruction call, and it's executed with value v1 from a stream. Yes, this one, because here you could see that we use iterator as in the argument of this call instruction. After execution of this call, when it's ready, then CQ calls next this right subgraph, and as I previously said, this next will move iterator to the next value. Here, next value is v2. Yes, and call recursively the body of this fault. Yes, and what's about the body? So the body here again, it's CQ. Yes, and this again, this CQ will be called. Yes, then there would be this pre-order traversal, and according to it, we will execute left subgraph this call with value v2 from our stream. Yes, and there is a question: what would be called here? Yes, because here we need to call next, and next so should like move iterator to the next value, but there is no more values on stream. Yes, it ends here, and as I said previously, so it will start to recursively come to the chain of calls, but here actually on the previous version of AquaVM, this instruction was implicit. So this was implicit instruction for different cases, like cases with par and cases with CQ. And now, after the latest changes, so semantic of fault was extended, and here we have like separate. So we have ability to put exact instruction that we want to be called when iterator was exhausted. Yep, and instead of this implicit semantics that depends on a body of fault, then semantic now is explicit, And here, instead of this implicit instruction, like this explicit instruction would be called. So why it's useful? It's useful because, so first of all, it allows you to carefully set semantics of a fault. For example, you could, and on Aqua, for example, it's used for different purposes and different work with streams. Especially so, we could consider streams as a stream from PyCalculus. As a stream from PyCalculus, it should never be ended. So, and for example, in this case, we'll put never instruction here. So if you carefully see, then this graph would be marked as not ended and not depending on the size of the stream. Why? Because this never will mark subgraph as incomplete, and if right subgraph of SQL is incomplete, then the whole SQL would be incomplete, and the same for this instruction at the head of this graph. Sorry, subgraph of fault. So, for example, this fault will never be finished. Yes, it will execute again and again according to the AquaVM execution model. So that's why, for example, it's important. And it was the first thing. Yes, it's the first thing to emulate PyCalculus streams. The second one is to allow using streams as like a building block for different types in the Aqua side, like structures and all of this. So streams internally uses for different types on the AquaVMs, on Aqua side. Let me say a couple of words at the end. So, like according to this change, also a lot of bugs were fixed on the AquaVM side. So some of them were found by more comprehensive tests. Some of them was like derived from a canon instruction, but all of them are fixed. And now we're working on the last bug that comes from incompatibility of fault and canon instructions that we found this month. And also we have some progress on the Marine side. So Marine is our WebAssembly, general purpose WebAssembly runtime. And here you could see in this picture the architecture of Marine. And we are working on so-called the refactoring that will allow us to abstract our used runtimes. There could be middleware layer here, and it would allow us to change these blue boxes in an easy manner. And also there were some like other changes that won't be so, so notable, but they're still needed. Like, for example, we finally update a horde of crates on the Marine side. We, for example, get some lean on the unsafe code on the AquaVM side. And also we have like a special form for air that intended for humans and allow human to read it more with less pain than just like this bracket-like syntax of air. And like in the previous months, the main crate that allows you to transform air to this form, it was changed in such a way that now it compiles to the WASM target, and eventually it will be integrated in the Aqua Run, Aqua CLI, and will allow you to, for example, see how. So actually, now you could see how Aqua compiles to air in which way. But after integration of this change, so it could be seen in like less pain. So probably that's it on my side. Maybe you have some questions.
Great. Thanks, Mike. Questions, anybody? Nobody. All right. I have two questions, Mike. When you say unsafe code, no more, that means Rust unsafe code, right?
Yeah.
Okay. All right. That's one. Just want to clarify that. And the second question is, with all this work taking place and some of it already being rolled out, some of it to be rolled out, does it affect anybody's existing Aqua code? What do people need to do to prepare for that? Is there anything need to be done? Is it backward breaking?
Honestly, I'm not sure because, like, as I understand now, it's not a breaking change on the Aqua side, but maybe Dmitry will say more about it because Dmitry is a developer of compiler.
Okay. Then I don't know if he's still on. Then for the time being, we go with no. All right, cool.
Yeah, I'm here, and yeah, I can answer this question. It can be some small differences between version that was before in Aqua, but I hope that there will be no changes in Aqua at all.
All right. Most excellent. That's what we want to hear. Improvements with no backward breaking changes. That's awesome. All right. Anybody else have any questions for the team?
Hello, everybody. Hello. Okay. My name is Joe. Okay, I have a question. Okay. We are planning for future development. I think we are going to build tools for Fluence. So, do you guys have any idea that what type of tools that you're gonna need, especially on the maybe application side for the development, or anything else? But we have anything about tools. Do you have any idea?
Still about somebody from the tools, DXJS. Anybody still on here? Huh. I guess not. I don't know. Does anybody know? Youth? Nobody. Got half the team on and nobody knows. All right. Do me a favor. Put your question in Telegram or Discord, and we'll follow up there.